Hello friends, welcome back to today's class of memory systems. So we have started with your new topic, which is read-only memories, ROMs. And in the previous class we have covered a number of things such as and in the previous class we have covered a number of things. To name a few, we have started with the introduction of the ROM. We have seen what actually is ROM, how it is built up, what are the internal ingredients of ROM, and how it is different from your RAM. So the major thing we saw is how it is different from RAM. So I hope you have understood the ROM in detail, what was ROM and all those things, and how it is manufactured using a single transistor and how it has two lines. One is bit line and another one is word line. Okay. So if you have any doubts, you can just have a recap of the previous video, and also you can call me or WhatsApp me with your doubts. Okay. So to moving ahead with today's class, today we'll move ahead and try to discuss the next very important part of your ROM, which we call it as PROM. So PROM stands for Programmable Read-Only Memory. So the name itself is telling you what it is. It is a ROM which allows the user to load the data, right? So that means you can say, does the other ROMs don't allow us to load the data? No doubt. They also allow you to load the data. But in programmable ROM, you can achieve programmability. That is, you can do programming in your ROM. That is, it will be telling you how the data could be inserted. But one very important thing here which is to be kept in mind is, whatever the data you insert, whatever the data you write inside that ROM, it could not be again erased. That is, the insertion of data is irreversible. That is, once you insert the data, you can see here, the insertion of data is irreversible. That is, once you insert the data, you cannot again delete it. Okay. Now, the next question arises is, how do we insert the data? How could be this programmability be obtained in your ROM? How can we obtain this programmability? Now, if I want to obtain this programmability, what we need to do is, we need to insert a fuse in our system. Now, what is my system? System you have seen yesterday. In the previous class, you have already seen the system. So the system here is nothing but it is a simple transistor. You have seen this transistor. I hope you remember this diagram. You have a word line here, right? You have a word line here and you have a bit line here. Fine. And what else you have, friends? Very important thing. Here you have a fuse. Or you can say here you have a switch. Here you have a switch. So this you already seen, right? So if I want to attain your programmability, one small change in this whole system I need to make is, I need to insert a fuse. I need to insert a fuse in this system. Right, friends? So where do I insert this fuse in the system? This fuse has to be inserted at the point where you have a switch. That is this place. So if I insert a fuse at this place, that is, I am denoting fuse with the help of a F. So if I insert a fuse at this place, then you will be getting programmability. Then we can achieve our programmability. Right, friends? So this is very important, how to attain your programmability. Now, whenever you do this, whenever you do the programming of the ROM, or before you do the programming of a ROM, the memory usually contains all zeros. This PROM, it contains all the zeros. Okay. Then the user, what he will do is, he will go on inserting ones. Then the user, what he will do, he will go on inserting your ones at the places where it is required. At what location he require, he will go on inserting this ones. Okay. Now this is very important, friends, that initially it is a 0. Then what you do, you go on inserting the ones. And how do you insert the ones? By burning the fuses. You have the fuses at some locations. whatever you have seen just now. At those locations you go on, what you will do, you will be go on burning the fuses. That is, you will be trying to implement the ones. So remember friends, when you try to burn the fuse here is what now? F. When you try to burn the fuse, it means that what you are doing, when you are burning the fuse, you are inserting a 1. And before burning, what was the memory contains? The memory contains zeros. So this is very important friends. That is, you can attain programmability by burning ones into the fuse. Okay. Now, how do you burn this fuse? These fuses are burned by passing high current pulses. So remember friends, how do you burn the fuses? By passing high current pulses. And why do you burn the fuses? To insert ones. And by doing all these things, what you are trying to obtain? You are trying to obtain the programmability of ROM. You are trying to program the ROM. But one major thing is what friends? Whatever the data you do at once, whatever the data you put at once, it is irreversible. It cannot be remodified. Like say for example, I want to put 100. Instead of putting 100, I have put 1,000. Then I cannot modify it. That is the problem with this PROM. But PROMs are very flexible and convenient. Remember, this is one major advantage with your PROM. They are very flexible and convenient, which was not available in your ROMs. Okay, so this is very important friends. What is PROM? Next, we will go to the next small modification in your PROM. You can say a next small enhancement in PROM. That small enhancement in PROM is nothing but your EPROM. Okay, so what is E now here? E is nothing but your erasable. See here friends, we had one disadvantage in your ROM. What it was, I tried to sketch on it a number of times. That is, once the data you push into a ROM, PROM, it cannot be reversed. It cannot be reversed. So that can be done with your EPROM. What are the disadvantage we had in your PROM? That could be, you can overcome that in your EPROM. So that means what you can do here, stored data to be erased and new data can be loaded. So what it does now, it allows the data to be erased and new data to be loaded n number of times. How many ever times you want to load the data, you can load on it. Such ROMs are called as erasable reprogrammable ROM, which we call it as EPROM. Okay. Now, next very important thing is its flexibility. Now, how this flexibility is important? It is very useful when you try to develop the phase of digital systems. Whenever I want to develop any digital system, at this case, its flexibility comes very handy. Now, what are these digital systems? This could be anything, like say for example your flip-flops, or say for example your counters. So when I want to do such things, or you can say resistors, these things you already studied in your third sem. Resistors, what do? They store the value. Resistors are different, resistor is different. Resistor you have studied in your AC. Okay, resistor is something again different, which is made up of flip-flops. This you have studied in your D, that is digital electronics or logic design. Okay friends, so these are very important EPROMs when you try to develop your digital systems. Okay, so this is one important thing friends. Now, how do you get this EPROM? This EPROM structure is very similar to what we had drawn just now, but only small thing we need to do is, when you might observe that in the previous video as well, I had drawn that transistor diagram. Only small change here is, we need to connect the ground made at point P. Okay, so apart from this, another major thing is, whatever the transistor we use. I had drawn this transistor, if you remember, I had drawn this transistor. Whatever the transistor we use in your PROM, is different from the transistor which we use in your EPROM. EPROM transistor, this transistor is different. PROM, this transistor is different. Okay, we use a special transistor which can function either as a normal transistor or it could be also function as a disabled transistor. So this special transistor is available in your EPROM, which was not available in your PROM. Now, this transistor can be programmed either as an open switch or it can be programmed as a closed switch. Now, one very important thing with this transistor is once you program it as a permanently open switch, then it will be remaining the same way. And how do you program it as a permanently open switch? By injecting some charges in it. Okay, friends. So this is very important, friends, that how your special transistor is helping you to do the work in your EPROM. Now, moving ahead, how the data which is stored can be erased. Whatever the data you have, that has to be erased, right? One second. Okay. So we're speaking of how to erase the data. That is the specialty of this EPROM, right? Now, how to erase this data is nothing but we will be dissipating the charges which are trapped in the transistors. First, what we do? We have the charges which are trapped in the transistors. Now, I want to remove those charges. Whatever the transistor has stored those charges, I want to erase those charges. How that could be done now? That could be done by exposing the chip to the ultraviolet light. So what we'll be doing now, in order to erase anything from your ROM, we will be shifting it to the ultraviolet line. That is, we will expose that chip to the ultraviolet light for a calculated amount of fixed period, so that EPROM chips have transparent windows. However, for all these erasing purposes, the chip has to be physically removed from the circuit. So this is one of the major disadvantage. That is, you have to physically take the circuit board and you have to remove that EPROM, and then we have to erase all the things. Now, this one major disadvantage led us to come across one more category of ROM. Okay, now what would happen here now? Whenever you try to remove the chip from the circuit, it might so happen that sometimes you would fail in removing it properly without any mishandling. That has to be avoided with this. So therefore, we consider this as one of the major disadvantage of your EPROM. Okay, friends. Now, next, coming to our last type of ROM we have is electrically erasable programmable read-only memory, which stands for EEPROM. Now, this, I told you the disadvantage of your EPROM. What was the disadvantage? We had to remove the circuit, we had to remove the chip from the circuit whenever we want to erase it. So that disadvantage has been overcome by EEPROM. So you can observe here the first point, to erase the contents of EPROMs, they have to be exposed to ultraviolet light. The second point, physically removed from the system. But what is happening with your EEPROM? Here it is no need to remove it. It could be erased electrically. All your data can be erased electrically. That means that means what now? What was the disadvantage? Removing the ROM from the chip. That has been avoided. Also, one more major thing here is the contents can be selectively erased. What was happening there in your EPROM? We have to erase the whole thing. But here we can erase the content selectively. Like say for example, I am filling the columns A, B, C, and by mistake I don't want to. By mistake, say I want to fill only A and B, but by mistake I have filled C also. I hope you are getting. I have an Excel sheet and I have 3 columns A, B and C. Then my intention was to fill only A column and B column, but by mistake I also filled column C. Now I want to erase it. That means I want to selectively erase only the C column data, but which could not be done if I had an EPROM. So therefore, if I have EEPROM, that is electrically erasable PROM, then that could be done by selectively selecting only that cell and removing only that content by passing the appropriate amount of voltage. So this is what is very much important or advantage. Another major advantage is that it is possible to read and write the contents of a single cell. There it was not possible to read and write the contents of individual cells, but here we can read and write the contents of a single cell. Okay friends, now we spoke of all the advantages. So when we have so many advantages, there has to be some disadvantages. So we have some disadvantages as well. The major disadvantage is that different voltages are needed for erasing, writing and reading. So I hope you understood. Like say for example, if I want to erase something, I need to pass some 5 volts. If I want to write, I need to pass 10 volts. If I want to read, I need to pass 12 volts. That means every time I want to make any certain procedure, I need to go on varying my voltage pulses. So this is one of the major disadvantage of your EEPROM, that is electrically erasable PROM. Now another major limitation is that each byte has to be erased separately. Now friends, here I just now gave you an example that by mistake I have filled C column, right? It might so happen that I have A to Z columns. My intention was to fill only A to C, but by mistake I have filled all A to Z columns. Now if I want to delete it, I have to go and individually delete each column entry right from D to Z. Now this becomes bit hectic with your EEPROM. The same which was a blessing to us has become a boon, has become a curse, you can say. Why? If I had mistakenly filled only one column, it could be easily erased. But if I had mistakenly filled 100 columns, then it becomes difficult for me to erase. So therefore friends, you can say the disadvantage under is that each byte has to be erased separately. So this acts like a trade-off. It could be advantage in some cases and it might turn into disadvantage in some cases. So I'll finish my today's class here only friends. If you have any doubts, you can just call me or WhatsApp me. Okay, thank you.